So hello everyone. Today we'll be discuss the experiment number 5 of data mining. So in the experiment, what we have told, like, we have to implement the FP growth algorithm, and our objective is to compute the maximal frequent item set. So we have to write a program for computing the item set of frequent item and their support counts for the given transactional data set. We have data set. First part we have to count the support counts of each item when we have to sort that. So we will move on to this example. This is the example from the handbook. Like, we have transactions like T1, T2, T3. These are some transactions. Each transaction has some items set like I1, I2, I5, I2, I4, these transactions. So first we will know the minimum support. Like, we can choose a minimum support like 2, and we have the choice to input from the user. So we can comment it. So now in the first part we have to calculate the support count for each item. So support count is just the count of item which has been there. So here we have created the item set, an ordered map which will map the this I1 to its count, I2 to its count, I3 to its count. So there is a for loop here. Uh, all transactions are traversed. Like, we have transactions I1, I2, I5, then we have I2, I4. So first T1 transaction will be traversed in this loop. In T1 transaction we have I2, I1, I2, I5. So in this for loop we will have I1, I2 and I5. So all the frequencies will be plus plus. Then again this transaction will be traversed I2, I4. So if that is already exists, its counts will be plus plus. After that this will be traversed and its count will be plus plus. So we'll have the results like here. Here we have the support count for each item in the terminal. Like, I3 is counting it 6. So I3 has come 6 times. Then I1 has come 6 times. Then I2 has come 7 times. So the maximum item set is I2, which has come maximum times, and I4 has 2 times. And we have chosen the minimum support as 2. So all are these are the valid transactions. So again, in the B part, we have to sort items in the transactions of the data set in L order. So L order is just the descending order. So here is this. This is for the printing of A part. Now B part is transactions sorted in L order. So what we have, like, we have all the transactions like I1, I2, I5, and we have to sort in the L order, like maximum to minimum. So maximum here is I2 count, which it was 7. I2's count is 7. And we have I1 count, which is 6. And then we have I5 count. So the L order would be I2, I1, and I5 for this. Then here I2, I4. So I2's count is here 7. So it is maximum. And I4 count is 2. So it is already sorted. Then we have I2 and I3. It is 7 and it is I3. It is already sorted. Here we have the printing the B part. Then we have I1, I2, I4. So I2 has the 7 count. I2 has 7 count. I1 has support count 6. So I2 come first, then I1, then I4. So in this way we have the sorted transactions. So moving on the code, we have traversed all the transactions. Like, first we will traverse one transaction in this, like this transaction. Then we will apply the sort function, which will take the argument transactions.begin to transaction.end. So it has taken the whole string I1, I2, I5. Then this is a comparator function. Comparator function is known for the frequency table. Like, we will return frequency table of A greater than frequency table of V. So item which has greater frequencies sorted is in the order first, and then after that we will print that transaction. So here we have print that I2, I1, and I5. Then we have see out that. So all the transactions would cover in the sorted L order. So there is a sorted L order. Now we will just have to move on the third part, which is construct the FP tree using the handbook example and display that FP tree. So for this transaction we have FP tree like this. This is the FP tree. How it has come? यहाँ पे I2, I1, I5 है, यहाँ पे I2, I1, I5 है. So in FP tree हमें नल से स्टार्ट करना होता है. लाइक, हमारे पास नल होता है, देन हमारे पास नोड्स आती हैं काफ़ी सारी, एंड देन वी हैव द लीफ नोड्स, एंड हर एक नोड के कॉरेस्पॉन्डिंग एक काउंट होता है. तो फर्स्ट ट्रांजेक्शन I2, I1, I5 है. तो सबसे पहले नल से स्टार्ट होके I2 I1 एंड फिर I5 आई। फिर हमारे पास सेकंड ट्रांजेक्शन है I2 I4, तो I2 तब दोबारा आएगा तो उसका काउंट प्लस प्लस हो जाएगा। फिर I4 आएगा, तो I4 अब यहाँ पे तो नहीं था तो अलग से नोट बना के यहाँ पे डाल दी। फिर मेरे पास I2 I1 I4 आया, तो I2 I1 यहाँ तक काउंट प्लस प्लस हो गया। अब I4 नीचे नहीं है तो हम अलग से नोट बना के यहाँ पे रखनी पड़ी। फिर हमारे पास I1 I3, I1 आया ही था नल के जस्ट पर, I2 था तो एक नई नोट बना के I1 लिखा और I3 आया। देन वी हैव I2 I3, हमने I2 लिखा और फिर I3 आ गया। I1 I3 अगेन I1 I3 पे उसका काउंट 2 हो गया, पहले 1 था अब काउंट 2 हो गया। देन वी हैव I2 I1 I3 एंड I5, सो दिस पाथ इज दिस। सो यहाँ पे काउंट जिस इसका इंक्रीज जो कॉमन था उनका इंक्रीज होगा, जो नई नोट थी वो बना दी। देन I2 I1 I3 I2 I1 I3, so this is the overall FP tree for this part. And moving out to the code, how we have implemented this. So here we have FP tree construction. So we have just the function build FP tree. About we have defined, we have the frequency table required, we have minimum support. Then after that we will print it. So moving on to the function build FP tree. This is the function build FP tree. Here we have a root null. Like in the starting, we must have a root null. So we just started with the root null. Then we will traverse all the transactions from the or transactions. We will take each transaction and then first we have to check if the minimum support count is valid for each frequent item. That the I2 if frequent item set is 7, then I1 is counting is 6 and I5 is counting is 2. So it is okay. So we have push into the vector. After that we will sort that in L order. Like here we will get the sorted L order. So we just store that sorted L order for better FP tree. Here we will use the same comparator function we have used above for sorting in the L order. और उसके बाद हम यहाँ पे इंसर्ट कर देंगे उस ट्रांजेक्शन को. सो वी हैव अ new insert function which will insert the transaction into the FP tree. This is our FP tree in the code. So insert transaction function is this. यहाँ पे हम हर एक आइटम लेंगे. So we have in just a second. यहाँ पे आइटम्स जो लिखा है उसका मतलब है ये पूरा डाटा सेट आया है, फिर हम उसके एक एक आइटम उठा रहे हैं. We have just first item. Then हम चेक करेंगे, सबसे पहले हम ढूंढेंगे कि नल से लेके अब तक क्या वो आइटम आई थी. सो वी विल जस्ट फाइंड दैट आइटम. अगर वो नहीं आई थी तो हम उसकी नई नोड बना देंगे. यहाँ पे हमने लिखा है न्यू FP नोड. यहाँ पे हम उसकी नई नोड बना देंगे इफ़ उसका चिल्ड्रन एग्जिस्ट नहीं करता होगा. एंड एल्स एल्स पार्ट इज दिस, इफ एग्जिस्ट करता है, अगर वो पहले आ चुका है तो हम क्या करते हैं उसका काउंट प्लस प्लस कर देते हैं. अगर नोड का चिल्ड्रन पहले था एल्स कंडीशन में तो हम उसका जस्ट काउंट प्लस प्लस कर देंगे और हम आगे बढ़ते रहेंगे. ठीक है. हमारे पास स्ट्रक्चर क्यों बनाना पड़ा FP नोड में, क्योंकि हमारे पास FP नोड में डिफरेंट डिफरेंट चीज़ें होती है. लाइक वैसे एक आइटम होता है उसके कोरस्पॉन्डिंग उसका काउंट होता है, उसके FP ट्री में उसका पेरेंट होता है, और हमारे पास FP ट्री में ही उसके डिफरेंट डिफरेंट चिल्ड्रंस होता है. जो चिल्ड्रंस हमारे पास उसके मैथ में स्टोर हो जाता है. राइट. हमारे पास FP ट्री ये था, तो यहाँ पे ये नल है, ये नल है. फिर हमारे पास I1, दिस इज I1. देन हमारे पास I3, दिस इज द चिल्ड्रन. सो ये यहाँ पे इसके नीचे आया है, ये चिल्ड्रन है. अभी इस नल के बाद ये I2 अलग नोड है, इस नल के बाद I1 के बाद ये I2 अलग नोड है, तो यहाँ से स्टार्ट हो रहा है. I2 का काउंट 7 था तो यहाँ पे भी देखो 7 है. फिर I2 के बाद 3 चिल्ड्रंस है, I1 I3 I4. I2 के 3 चिल्ड्रन है, I3 I4 एंड I1. यहाँ पे भी यही I3 I4 एंड I1. फिर उसके बाद I1 के अगेन काफ़ी फर्दर चिल्ड्रंस है, तो I1 का फर्स्ट चिल्ड्रन I3, I1 का चिल्ड्रन है I3. उसके बाद I3 का चिल्ड्रन है I5, यहाँ पे स्टोर हो गया. फिर I1 का चिल्ड्रन है I4, वो यहाँ पे रहा. I1 का चिल्ड्रन है I5, वो यहाँ पे रहा. सो हमारा FP ट्री सही से जनरेट हो रहा है स्कोर के थ्रू भी. ये हमारा इंसर्ट कर रहा है कोड को, और वो हमारा बिल्ड कर रहा था. बिल्ड में हमें पहले चेक करना था कि वो मिनिमम सपोर्ट से ज़्यादा है या नहीं है, और उसके बाद सॉर्टेड ऑर्डर के साथ ही हमें FP ट्री बनाना पड़ता है, तभी वो सही बनता है. फिर हम रिटर्न करते हैं रूट को, जो कि यहाँ पे जाके हमारा रिटर्न हो जाएगा. एंड देन वी विल प्रिंट दिस FP ट्री. This we had printed the FP tree. So this is the C part of FP tree construction. Thank you.
I am going to explain how our pattern bases are generating, and the pattern base, there is a associated conditional fp tree and their associated fp tree how this generating. So basically in this we are using a for loop. In for loop we are passing all the items from the frequency table. So firstly we are checking the count of the item. If the count of the item is greater than minimum support, then we are calling a function extract pattern base. In extract pattern base we are passing the root of the fp tree and that item and the pattern base which we have created there. It is a vector in which we are storing a pair of string comma int. So string is basically for the prefix path and int is for the count. So now moving to the extract pattern base function. So now in extract pattern base function we are using a for loop again for traversing all the childs of that node. And if that child is null, then we are doing nothing and moving to the another child. And if the child matches with the item, so we are going to store the prefix path of that item, because this is the item we are going to find and we have found that item. So now we are calling a while loop for storing the prefix path. In this we are just doing like, if the parent of the node not equal to null pointer means item is present, then we are storing that item. Also if prefix path is empty, then we are storing nothing, but if some element is already present in the prefix path, then we are adding comma for that. So in this way we are storing the prefix path of the item we want to find. And then the prefix path we have found, we are pushing that prefix path into the pattern base we have created, which is in the form of vector. So also with the prefix path we are storing the count of the element. And if the child is not equal to that item, then we are again calling the extract pattern base function for the another child. So let's see the output what is coming from this function. So so here we are getting the pattern basis for every node which is present in the fp tree. Like for the pattern base for I3, we have three prefix and their associated count. I1 with count 2, I2 with count 2, I2 I1 with count 2. So same like for I1 and for I2. So till now we have created our prefix and their counts. Now in the another part we have just printed this using this for loop. And now we have to build conditional fp tree also for the pattern basis we have generated. So for this we are using a print fp tree function again, which we have talked about in the fp tree part already. So using this we are creating the conditional fp tree. Conditional fp tree is different from the normal fp tree. In this fp tree we create the fp tree for a particular node from the pattern base of that node. So basically what we are doing here is merging the elements which belong to the same branch. Like here for the pattern base of I3 we have prefix I2 with count 2 and I2 I1 with count 2. So here I2 belongs to the same branch. So what we are doing, merging this I2 with the associated count. So here we have created null node and then I2 with count 4, which comes from the 2 plus 2 part. And then there is I1, which is from the third part with count 2. And there is another I1 which is from the first part with count 2. Similarly, we have created conditional fp tree for I1. So here prefix part is I2 with count 4 only. So we have created this conditional fp tree. And another fp tree, conditional fp tree is for I2. So here is null, as no pattern base is present for the I2 part. So now moving to the next question.
Now, after generating the conditional FP trees, we are generating frequent pattern for these respective conditional FP trees. Now, for this, first of all, basically, we are storing these unique patterns in an unordered map with string and int. Now we will traversing on the frequent table by using the for loop, and in every iteration we get item, and then we check if item dot second means basically its count is greater than the minimum support. Then we will generate frequent pattern for this by calling the generate frequent pattern function, in which we will pass fp tree root item unique pattern and minimum support as an input. Now we will see about the generate frequent pattern function. Now in the generate frequent pattern function, first of all we will traverse this node children's using the for loop, and in every iteration we get child, and then we will check if child dot second count is greater than or equal to minimum support. Then basically we will create a string that is new base, and if we check a condition, if its base is empty, that is empty initially, then we will add this child dot first in the string, and if its base is not empty, then we will append this child dot first in the pre-existing base, and then we will update the result index value in the result array by the child dot second count, and then we will recursively call this function generate frequent pattern by passing child dot second new base result and minimum support as new parameters. Now here there is a view of the frequent patterns that are generated by the conditional FP trees. Like these are the six frequent patterns that are generated from these conditional FP trees: I2, I2, I1 with count 4, I2, I2 with count 7, and similarly other 4s. So this is all about the FP growth algorithms. Thanks for watching the video.